Okay. Hi everyone, my name is Stasaski. I'm a PhD student at UC Berkeley, and I'm presenting on some work that's been done with some collaborators, Marty's here, and some other students who have been working with me on this project as well. So the overall goal of our work and what we're trying to do is we're trying to create an automated tutoring system which converses with students via dialogue to help answer a question. And all of this interaction is going to be grounded with a shared representation that both the model and students working through the question will see. So to contextualize this a little bit, we're dealing with the domain of foreign language learning, and particularly two different instantiations of this. So the first case is when a student is trying to learn the name of a colored shape. So in this example, they're trying to learn the word, the translation for red star in Italian. There's the question and the answer accompanying that. The other, more complicated case that we're interested in is prepositional phrases that involve colored objects. So in this case, the student is trying to fill in the blank. The cat is on top of the red table in Italian. So they're given the first half of the question, the translation for cat. They're being asked to fill in the second half of the sentence. So these two use cases are linked by the common vocabulary of the colors that are being used in the foreign language. But the second situation includes more complex vocabulary and grammar rules that the student needs to understand in order to answer the question. So I have a sample interaction of our system that I'd like to work with throughout this presentation. So this is for the case of the prepositional phrase example that we just looked at. So the tutor asks the student, please try to fill in the blank. The student maybe asks a question. So how do you say table in Italian? The tutor answers the question and then asks the student back, do you know how to say red? The student says, okay, I think red is rosso, and then they make a guess at what the phrase is. Then the tutor provides a slight correction that since the word is masculine, you need to use one word instead of the other. The student ultimately gets to the correct answer. So the framework in order to create an interaction like this would involve several inputs to a model. So there are the facts that the student needs to learn. These include the vocabulary and the grammar rules that the student needs to understand and internalize. There's the image, so the actual thing linking what a student is trying to translate as represented in this animated world. And also we want to incorporate some information about a student. So those of us who have tutored know that your tutoring style can change with how a student responds and how they interact with you. So we want to incorporate some representation of the differences between students and what they've said in the past when creating a model response. So all of these inputs go into a dialogue, which is the tutor-student chat interaction to try to get the student to learn the phrase in the foreign language. So I mentioned a shared interaction, but what does that actually mean? So in order to have a deep learning or machine learning model, it needs to be grounded in something other than conversation. So if the model just sees words describing red and square with no actual interpretation of what that means, it's a lot harder for the model to learn what's actually going on and when to deploy those concepts. So we're drawing on past work, which has grounded a model's representation of color and shape objects in both an image and a tutoring dialogue. So the past work was trying to ground a representation of what these concepts were using language, but we're trying to do the inverse of that. So we're trying to ground a representation of how do you generate the language based on the image that the model is being presented with. So we have a few unifying task properties. The first is that we have the image that grounds the interaction, and both the student and the model see that. The second is that we're dealing with the domain of dialogue, so we're trying to use dialogue to both diagnose misconceptions that the student might have, and to try to determine student understanding of certain concepts that they ultimately need to know. And ultimately, we'd like to really have a focus on the language of teaching and how effective tutors are effective tutors based on the techniques that they're deploying. So in order to do that, as the last speaker alluded to, we need a relatively large data collection. We need a relatively large data set, so we've developed a process to do so. So we need a large amount of training data to train a machine learning, a neural network model. The benefits of training a neural network is that we have more generalizable, it's able to more generalize to different student conditions, and we're able to generate more diverse language. So instead of kind of the dumb tutoring model that you might interact with, which might say the same thing no matter what you input, We want to have a model that generates different, interesting language that the student can interact with to keep them engaged throughout the process. So in order to collect a larger data set with these goals in mind, we turn to crowd workers on Amazon Mechanical Turk to collect student-tutor interactions. So a little bit about our data collection process. We start by collecting student conversations. So a student goes into our interface and is interacting with what they think is an instant tutor that's being serving responses to them. So we're getting these responses from the two places on the left. We have rule-created responses that we start with, which the researchers put together as pretty simple ways of conveying messages that we want to convey to the students. We also have responses that past tutors, real people, have generated. These have more diverse language, which I'll show a little bit more in a bit. So we collect a round of student conversations. We have examples of students interacting with a tutor. We then feed that into other crowd workers who are role-playing the part of the tutor. So one interesting phenomenon you can observe with tutoring language is that different tutors will say very different things, take different actions when presented with the same student stimuli. So this is important and unique and something that we wanted to capture with our data collection process, because when we think about training a downstream model, we want to be able for the model to deploy different strategies if something isn't working. And we want to emphasize that all of these strategies are correct, valid things that one could say to a student while taking drastically different actions. So in order to capture that with our data collection process, we show each part of a student conversation to 3 different crowd workers who are role-playing the part of the tutor. We collect a response from each of those, and then we feed them back into the tutor-created responses that we serve to students later on down the pipeline. So we're doing this in an asynchronous way. We're collecting student conversations, having tutors respond to those, and then serving those tutor responses back to future students to get other student interactions. So I'd like to step a little bit more into detail of how we're actually doing this, and start with how are we collecting the tutoring responses from crowd workers, and how can we actually have a crowd worker be a valid tutor who can respond correctly to students. So first, we're providing crowd workers with vocabulary and grammar rules. So I've pulled out a subset of these rules on the right. So these include, for prepositional phrases, there's the color word, the actual prepositional phrase, and the object that's involved in that relationship. We also have grammar rules, so when to use the masculine versus the feminine form of certain color words, when to use different contractions based on the gender of the object, and so on. So we're providing a list of this all to the crowd workers who are role-playing the tutor to give them all of the information that they need to know to respond to the student. So we're not requiring that they be fluent in Italian in order to participate in our task. Also, I mentioned in the past that we want to provide student summaries. So we want to have a representation of what a student has done in the past. That doesn't take a huge cognitive load for the tutor crowd worker to process. So we're condensing down up to a 20-turn student conversation into a table and high-level summary that we're showing to the tutor workers. That way they can use information from what the student has done without reading through all 20 turns of those lines. So I'd like to show kind of a bigger example to point out some things about how we're creating these tables. So the table of student information involves relevant questions that a student has attempted to answer before the current conversation that the tutor is responding to. And we're selecting these based on those that have similar properties. So if the student has been served a question in the past that involves the same prepositional phrase, we would include this in the table because the student's incorrect guesses or misconceptions might be relevant to the tutor responding to the conversation at hand. But in addition to the table, we wanted to prompt and seed the tutors with how they should maybe interpret this information with their current response. So that's what's happening with the 2 sentences under the table. So we mentioned that the student has gotten the word for table wrong 1 out of the 2 times that they gave a guess. So this indicates that the student might not know the word. So we draw these higher level themes, we convert them to text, and we say maybe how the tutor should think about the student as a whole, things that they should consider. So we would expect somebody to maybe take this information and maybe outright ask if the student knows the word for table, since they've gotten it right once but incorrect the other time. We're also providing information about how many hints a student has had to receive about a concept. So this also provides kind of a signal for concepts that a student might know and guess correctly versus things that they might not know and need to receive a hint for in order to correctly answer the question later. So the final thing to consider when crowd workers are playing the role of tutor is that they're labeling their actions. So for machine learning models, it's better to have kind of a discrete action space of things that a tutor can do at a certain space associated with different language. That way the signal's less noisy and we have explicit one-to-many relationships of the semantic actions that a tutor can take. So if we take our past example of the tutor saying, tables, tavolo, do you know how to say bread? That includes two actions that the tutor's taking. They're revealing a piece of information to the student and they're asking a question of the student. If you look at the last example, the tutor says almost and then provides the correction. So since tavolo is masculine, you should use al instead of ala. So that's the correcting the student who's made a guess in the past. So once we have the tutor responses, I want to go a little bit more into how we're getting the student conversations. So as I said before, we have 20 turn back and forth interactions with our system. So our system is serving a tutoring response to the student that tries to respond to what the student has said. So I'd like to go a little bit into how we're doing that. So I mentioned the two different situations, the rule-created responses. So those are things that we, the researcher, have written up to give hints to students, to ask students questions and scenarios that may be appropriate. So in order to do that, we parse the student action, so which action is the student taking at a certain point. We choose a type of response that we want to have, and then we produce the output. That's the line on the top. But we also want to serve tutor-created responses. So for that, we would parse the student response. We would choose a past tutor response that's responding to a student in a similar situation. So we're utilizing word overlap to see if what the student has just said is similar to a past student that a tutor has responded to. Then we adapt the tutor response to the current situation, the current vocabulary the student is trying to learn. And if you look at the difference between these two interactions, the two resulting conversations that we get shown to the student, you can see that one of them has more diverse language, one might be a more interesting hint for the student to read, kind of rule-based responses that we start with. Additionally, we're incorporating multiple questions since we want to get examples of students learning things over time. So for these image examples, the student might start with a question about a cat inside of a box. We'd maintain that same first object, the cat, when serving the student their second question. So we want to maintain some sense of similar vocabulary over time. That way we can study how student responses change when they're assumed to know or at least have been exposed to certain vocabulary words. Then from the second to the third example, that's similar. The second object, the tree, stays the same, but the prepositional phrase and the color changes. And finally, we also have the students label their actions. So the student labels if they're asking a question, such as in this example, or if they're affirming something that the tutor has said, okay, or that makes sense, and then making a guess. We also have them label all of their guesses. So we utilize this back and forth process to create two different data sets, one for each of the domains that I mentioned at the beginning. So for the colored shapes data set, we have 350 unique conversations with about 3,000 tutor responses to those conversations. Again, with multiple tutors responding to the same point in conversation. We have a similar size data set for prepositional phrases. I'd like to take the last minute to just go through some sample tutor responses of some interesting phenomena that we observed and some interesting language that a future model could potentially use to respond to other students. So the first two are examples of tutors who are including information that we're seeding them with, but might have a more standard way of responding to a student. So look at the order of your words again. Adjectives such as color words follow the noun that they modify in Italian. That's correct, they're utilizing the information, but it's not being as creative as, say, the second two tutors, who are trying to draw comparisons to something in English. So the third one, a dentro, the tutor mentions that it sounds like dentist, so here's a way that I would think of it. And the last one talks about comparing dentro to something like indent or dent, which would happen inside of something. So we observe these kind of unique, kind of interesting tutor responses to different students that we hope can allow us to capture a more engaging way of responding to students when we eventually use this in a downstream model to generate these utterances automatically. Okay, awesome. I'd like to open it up for questions, and thank you all so much.
Why did you pick this particular task with colors and objects? Is it because of the simplicity and the structure? And if so, how do you think this approach would scale to more generally speaking languages?
Yeah, that's a great question. So we really wanted a task that incorporated images because we felt that would be a great way of grounding a dialogue machine learning model. So we ultimately wanted to think of foreign language learning because there's the obvious like translating something that you're actually looking at. We've also been thinking about the terms of science questions that involve diagrams, but since those images are much more complex to represent, we wanted to start with something that was a little bit simpler. So I feel like our approach would scale, but there might need to be some more innovation on the representation of the image side in order to do so. Yeah, sure.
So, a lot of this, the ideas here are like grounded in pedagogy, so I like the things that you're doing, like you are relying on what other people have learned in the past to teach other things, so great work and incorporating it. The ideas in learning and estimation learning, it's not like blind things that you're throwing things at machine learning data, right? So the thing is that one thing is I want to ask, are you aware of Joseph James Williams' group work on explanation generation in the multi-arm bandit context? So that's very relevant to things that you're doing here. And I have a clarification question from one of the slides.
Sure.
So the crowd workers are choosing responses, right? So here,
Yep.
So do you give them options to pick or they are going to?
Yeah, that's a great question.
Yeah.
So we have a set of pre-made classifications. So
Right.
they're typing the text from scratch.
Oh, okay.
Yeah, so the text is from scratch, so we want to get diverse language, and then we're having them choose. We have a few pre-made actions that they can classify their text as, and that's
How many
based
types do
in.
you have?
So we have 4 for the student and 5 for the tutor.
Okay.
And then we also allow for the option of other, so they can self-define.
Right.
Yeah, we find that they sometimes utilize that to combine classes together. We haven't
Right.
seen anything super interesting come out of it.
Yeah, I have had that. I've done a lot of crowd sourcing. I mean, I have a much broader range of classification, big taxonomy. It's hard to understand some of the types. So I think you probably chose types that are simple enough for crowd workers to and make sense of what those are. Right?
Yeah, I guess we were also utilizing a pre-test, so we encourage workers to complete classification of pre-made responses as a pre-survey to completing this. So we tried to impart some knowledge as to what these actual classifications mean so that they wouldn't get confused and reclassify their own.
Right, I mean, you mentioned pre and post. Are you doing some assessment also on if the learners are learning something?
So we haven't done that yet. So
You're planning though?
we want to maybe examine it, but the interactions for the students are only over 20 turn conversations, so it's a little bit harder to measure. They're all done in the same sitting.
Right.
So we do have some triggers that respond, that'll come back and do the task again, but we haven't started to look into that data yet.
Cool, thanks.
Oh, actually, yeah.
So far this is all text, right?
Yes, yeah.
So I'm at Rosetta Stone, so if there's one thing we have, it's a lot of images
Right.
and a lot of tutoring sessions where people discuss pictures in the foreign language. Usually with a live tutor, but it's in real time, it's code in real time.
Right.
And then there are some programs that use chatbots that aren't using a speech synthesizer yet, it's all just text. I wonder if you think this would be useful for sort of a virtual avatar type tutor where we really want to get our students speaking, right?
Yeah.
So we really want them to practice speaking out loud with a human or as close as possible. So just say a few words about that.
Yeah, of course. So I think definitely practicing a foreign language out loud is really important for learning. And I feel like the way that we've designed our system, you could add on a module that goes from text to speech or speech to text at the end. So I feel like that's something that could definitely be added on and used to extend our methodology, but not something that we're particularly focused on right now. We kind of want to remove that and focus more on what we know is the content of what the student learns.
We have time for one last question.
How do you curate the crowd workers' responses? Because some of them could be wrong or not that good dialogue. And I think one of the examples you showed had something incorrect in it. But
Pardon?
I think one of the examples you showed might have been incorrect. I'm not sure.
Oh,
but-
yeah,
Or
yeah,
at
so-
least add typos, and I think my.
Yeah, typos are something that we can't really get around, but we're manually removing or rejecting workers that have very, very off-task responses.
Yeah.
But we wanted to keep in workers who, we can't classify all of the typos, we can't classify all of the missteps, but we figure that with enough data that'll work itself out. And also this is kind of attuned to peer learning, so peers make mistakes when they're tutoring each other, so that's something that we wanted to account for in lieu of actually going out and hiring tutors.
That's good.